Take a close look at these two specimens. To the naked eye, they look exactly the same, sparkling, heavy, and metallic. For centuries, early alchemists and natural philosophers assumed that if two things looked identical on a table, they were made of the same basic stuff. They built their entire understanding of the physical world by sorting materials purely by their color and surface texture. But relying on human eyesight created a massive problem in early laboratories. Mixing materials that looked similar often resulted in wildly different, unpredictable, and sometimes dangerous reactions. To figure out what matter was actually made of, scientists had to stop trusting their eyes. They needed a completely new way to judge the materials they were studying. Trusting our visual perception was the primary barrier to understanding what the material world is actually made of. This brings us to the 8th century laboratory of Jabir ibn Hayyan. He wanted to organize this messy material world, but instead of staring at rocks, he put them to work through physical experimentation. As we can see in this sorting diagram, Jabir initially established two main behavioral categories. First, he identified metals, materials that can be heated and hammered into shape. Second, he defined spirits, substances that simply vaporize into the air when exposed to a flame. That system left him with an unavoidable anomaly right on his workbench. He had piles of hard, unyielding solids, like salts and minerals, that refused to melt smoothly and certainly didn't evaporate. These uncooperative solids represented a gap in human understanding, and they could not be explained by his existing rules. Jabir selected sulfur-containing minerals as his primary subjects to investigate this blind spot in his research. He subjected these minerals to punishing conditions. They were crushed, roasted, and drowned in harsh chemicals to see how much physical stress they could take. When gold or silver gets hot enough, it pools into a smooth liquid. Jabir observed that these sulfur minerals did no such thing. They completely resisted melting gracefully into a fluid. And when he took a hammer to them, they didn't flatten out. They were brittle, fracturing and shattering into pieces upon impact. Because they consistently failed to stretch, bend, or melt, Jabir had the concrete evidence he needed. These materials belonged to a different taxonomy family entirely. Jabir shifted his focus. He looked past how a material sat on a shelf and prioritized how it acted in the heat of a furnace. This shift led him to formally establish a third chemical classification, giving it the name stones. Watch the flowchart update. A stone must pass 3 behavioral tests: be non-malleable, resist melting, and display unique reactivity. With these concrete rules, the leftover chaotic solids finally had a home, filed systematically into an organized framework. Sorting materials by their physical reactions allowed scientists to anticipate what would happen before they even lit a fire. Classification became a tool to predict the behavior of matter. This marked a turning point in science. It was the first time a major category of matter was defined entirely by its invisible behavioral traits. Jabir's methodology offered an alternative to the older, more mystical ways of categorizing matter based on appearance. This logic bridges the gap between an 8th century laboratory and modern science. Today, we recognize chemical compounds as the high-resolution descendants of Jabir's stones category. Jabir's tests observed the physical outcomes of what we now identify as atomic bonds. A material's atomic structure dictates its physical properties. When modern chemists classify compounds today, they utilize the same behavioral logic Jabir used at his crucible. Jabir ibn Hayyan demonstrated that to understand the material world, we must look past the surface and measure how substances behave under pressure.